Welcome to Statistics. This is the very first lesson for the unit, and in this chapter we'll just be looking at some important vocabulary and definitions to highlight, and we'll also focus on the difference between a sample and a population. Here are some definitions. First, statistics is the collection, organization, summarization, and interpretation of data. A population is the complete collection of all elements to be studied, whereas a sample is part of the population. In Section 1-2, please read the section, but homework is not assigned. The main idea from Lesson 1-2 is to understand the difference between statistical significance and practical significance. It's possible when we use methods of statistics to reach a conclusion that finds that some treatment is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. In your textbook, see example 6 on page 7 for more information about this. Now let's look at different types of data. First, a parameter versus a statistic. A parameter is a number that describes an entire population. For example, there are exactly 100 senators in the 109th Congress, and 55% of them are Republicans. The percentage 55% is called a parameter because it's based on the entire population of senators instead of coming from a sample of the senators. A statistic is a number describing a sample of the population. For example, in 1936, Literary Digest polled 2.3 million adults in the U.S., and 57% said that they would vote for Alf Landon for president. The figure of 57% is called a statistic because it's based on a sample, not the entire population of all adults in the U.S. So one idea or one way to keep these straight is to identify parameter with population, they both start with P, and statistic goes with sample, and they both start with the letter S. Let's look at some examples to identify whether the value is a statistic or a parameter. First, in New York City there are 3,250 walk buttons that pedestrians can press at traffic intersections. It was found that 77% of those buttons do not work. So the value that we're focusing on in this problem is this percentage, 77%. Is that a statistic or a parameter? Well, this is a parameter because 3,250 represents all of the walk buttons that exist. And so the value 77% is identifying a percentage for all of those, so that would be a parameter. The author randomly selected 35 movies and found the amount of money that they grossed from ticket sales. The average, or mean, is $123.7 million. Now this time the value that we're trying to identify as being a parameter or statistic is not expressed as a percentage. It is the $123.7 million. Now this is a statistic because 35 movies is a sample of all movies made. Now let's look at two different types of data that we'll be studying. There's categorical data, which is sometimes called qualitative data. In this instance, data are categories. Categories could be names or labels that are not numbers representing counts or measurements. Examples could be genders of athletes, eye colors, data from interviews. Then we have quantitative or numerical data. In this instance, data are numbers for the most part. The numbers represent counts or measurements that were taken. One example of quantitative data that's not numerical would be true or false answers. You can turn that into quantitative data by assigning a value for true and a value for false. We also need to know the difference between discrete data and continuous data. For discrete data, we're looking at countable values. Examples could be the number of people in a room, the number of eggs a hen lays. Continuous data is usually expressed as a measurement, and that's because we can express a measurement with more and more precision if we use a continuous scale and measure out to more and more decimal places. So any type of data that includes measuring or weighing something would be continuous data. So an example of continuous data would be measuring the amounts of milk from cows, measuring a person's weight. Here we want to identify if the given values are from a discrete or continuous data set. In the Literary Digest poll, Landon received 16,679,583 votes. Now votes are countable, so this would be discrete. The volume of cola in a can of regular Coke is 12.3 ounces. Now even though the decimal terminates at 12.3, we could measure the volume with increased precision. So this would be continuous data. You need to also understand the levels of measurement of data expressed in this chart. We have 4 different levels: nominal, ordinal, interval, and ratio. Nominal data is for data that's categorical only. The data cannot be arranged in any kind of an order. For example, if we determine the states where students in a class are born and we find that 5 are from California, 20 from Texas, and 40 from New York, that data is nominal because you can't determine an order for those states. There is no order for those. Ordinal data is also data that is categorical, but you can determine some type of an order or sequencing. So, for instance, the types of cars owned by students was found to be 5 compact cars, 20 mid-size cars, and 40 full-size cars. So the data is compact, mid-size, and full-size. That's categories. And we can also identify a type of order to these names: small, medium, and large. So that would be an example of ordinal data. Then we have interval data. This is where differences are meaningful. We have numbers, but there's no natural zero starting point and ratios are meaningless. Temperatures is a very good example of interval data. 5 degrees, 20 degrees, and 40 degrees are all that numerical data, but 0 degrees Fahrenheit doesn't truly mean zero. It doesn't mean no heat. It's just a value on the scale. 40 degrees is not literally twice as hot as 20 degrees. So you can't really multiply your temperatures by a ratio and it actually means what it's supposed to. The final level is ratio. This is where we do have a natural zero starting point and we can do some comparisons with our numbers, like multiplying by 2 or multiplying by half, and the ratios are meaningful. For instance, students' commuting distances were found to be 5 miles, 20 miles, and 40 miles. Now with mileage, distance can be compared, and 40 miles is truly twice as far as 20 miles. So that would be an example of ratio data. Let's determine which of the 4 levels of measurement, nominal, ordinal, interval, or ratio, is most appropriate. Types of movies: drama, comedy, adventure, documentary, etc. That would be an example of nominal data. This is because we have categories, but there's really no way to order them in terms of a sequence like first, second, or third place. Then we have actual temperatures in degrees Fahrenheit. This is always going to be an example of interval data. Measured amounts of greenhouse gases emitted by cars is ratio data. Because you're taking measurements and those values you can express as ratios, you can compare them, and 0 tons of gas literally means you have no gas. Ranks of cars evaluated by Consumers Union. This would be ordinal data. There is an order to the categories. So let's determine if we have a sample and a population and what those are, and is the sample a likely representative of the population. A Gallup poll of 1,012 randomly surveyed adults found that 9% of them said cloning of humans should be allowed. So the sample would be the 1,012 people that were surveyed. The population would be all adults. And since the subjects were told to be randomly selected, then we can assume the sample is likely to be representative of the whole population of adults. Let's identify the sample and population. America Online asked subscribers to respond to the question, which slogan do you hate the most? Responders were given several slogans used to promote car sales, and Volkswagen's slogan received 55% of the 33,160 responses. The Volkswagen slogan was, relieves gas pains. The sample here would be the 33,160 people who did respond. And then the population, instead of being all adults, would actually be all American Online subscribers. Now, since this is an example of a voluntary response sample, then we can't assume that the results are likely to represent the entire population of AOL subscribers.